have uh, differentiated experiences with networks and networks in cloud. I will try to kind of keep it as simple as possible. While it is a bit of complex subject, no justice can be done to this subject in a 90-minute session, but I'll try to keep it at a level where the key takeaway from this session would be to understand what network is when you talk about cloud, what you can benefit from network in the cloud, and whenever you do a conversation related to networking in cloud, what are the areas that you should definitely be talking about. Either you are a developer or an infrastructure engineer or a cloud network engineer or an on-prem engineer, there are certain things which always should be brought into the mix when you're doing a conversation regarding networking in cloud. And those are the aspects which I will try to cover in my session. When it comes to networking, it's all about numbers. um, and these numbers sometimes are confusing. I'll try to clear the mystery around the numbers before I really jump into what these numbers mean uh, when the different cloud providers talk about it, right? So there's something called as a region and a zone, which I believe most of you would be clear by now. People who have attended previous sessions will definitely know what is a region and a zone. A region is something that any cloud provider say that I have a presence in this place. A region is broken down into various availability zone, which means a given availability zone is different from second availability zone in terms of failures. For example, if there is a presence of Google Cloud in Mumbai, Mumbai is a region. Mumbai Zone A and Mumbai Zone B are two zones within that regions, and they are standalone entities in terms of their power supplies, in terms of their connectivities, etc. So region and zone is something that is important when we discuss networking. The other most important part is called as point of presence, also called as POP. Some people call it as edge. But fundamentally, what is POP? A POP is a place where your network marries a third party network. For example, in India, all of you are dialing in from one of the ISP network. You guys might be on Airtel network, some of you might be on Vodafone network, Tata network, Reliance Jio network, etc. If you have to access an application which is hosted on the cloud, your internet service provider and Google's network might be meeting at one point. That point simply is called as a point of presence. This is where our network marries a third party network. The richness of this number fundamentally tells the number of places where you can cross the boundary and get into Google's network. And hence, this number is indicative of the fact that no matter where you are coming from, no matter which place you are coming from, which ISP are you coming from, you can get into Google's network to access the application which are hosted from these many locations. A lot of people may be using term edge, fundamentally the same thing. Now, what is caching location? Also known as CDN location. A lot of you, in fact, most of you would have experienced what YouTube is. A video that you play on YouTube most of the time gets played from a location which is called as cache location. So there is a location where your favorite song is stored, that is called as the origin location. But when you are playing that song from your home, there is a very high chance that that is played from a location which is called as a cache location. Cache location is the location which is near to you, which is near to the user. And the reason we have cache location is so that we can have a content delivered to a user as soon as possible. And these numbers do matter. 100 plus is what I'm saying is for one of the CDN number that I will talk about. Other numbers which is dedicated interconnect. This is this is the number which reflects if you have a data center in India, or if you have a data center anywhere in the world, and you want my data center to talk to Google's infrastructure, how many points can you kind of go and connect to? So for example, let me take an example. If you have your data center in Mumbai in India, can I directly go and connect my data center to Google's work location? Yes. So that if there is a dedicated interconnect location, that is what that number mean. I don't think apart from that, from a networking point of view, you need to know any other number. You should know what a region is, you should know what a zone is, what is a point of presence, what is a caching location, and how many locations can I connect my dedicated interconnect to. Now that once that is understood, I'll go and kind of explain two terms that generally are confusing. Some people who are from networking industry um, might correlate terms like hot potato routing versus cold potato routing, but I'll keep it very simple. If you are a user who is, let's say, sitting in Germany and you want to access an application which is hosted on Google Cloud in Mumbai, fundamentally there are two ways that you can access this application. First is from Germany to Mumbai, you come on an open internet and then you enter into Google Cloud in Mumbai. That is called standard, which means for the majority part of source to destination, you are on open internet. Versus there is something called as premium, which means if you are in Germany and you want to access an application in Mumbai, you get into Google's network in Germany itself, which means for the majority of source to destination distance, you are on a premium network, which is Google's network. Fundamentally, that is the difference between premium and standard. Why this is important and why I'm talking about this right in the upfront, like first 5 minutes of my presentation, is because this is where a lot of networks are different. If I'm a novice and I don't know anything about network, if my web page is loading slow, I might simply say that my network is not performing well, right? If there is a kid at the home whose laptop doesn't work, he or she might go to his parents and say, Mama, network is not working fine. That's why I'm not able to browse to my favorite website. But fundamentally, behind the scene, the technicalities of this is what network is your traffic riding on? Is it a premium network or is it like a standalone network for which you don't have any guarantee? A open internet is a network on which you don't have any guarantee. You might be lucky to get the page loaded ASAP, or you might be unlucky if the page loads after a few milliseconds or after a few seconds also. So just keep in mind that whenever you are doing a network conversation, it is important to know that which network are you riding on. Is it a premium network or is it non-premium network? Now, when it comes to networking conversation in any cloud, or for that matter, any networking conversation that you might do, it can be fundamentally broken down into four areas. Now, those four areas, if I may say, are connect, secure, scale, and optimize. Let me put some more light to it. Connect is how do you as a user connect to your provider. If you are a user and you want to access an application which is hosted on Google Cloud, in how many ways can you connect? How fast you can connect, how securely you can connect are different flavors of it. But how do you connect to the network is the first building block. Now, this connection has to do with end user connecting uh, to a hosting location. This also has to do with different hosting locations talking to each other also, right? So, for example, if I have a web in Mumbai and a database in Singapore, how do they talk to each other? That is also an aspect of connect. The second is once you have done your connections, how do you secure? So everybody talks about I am done with the connections, but I need to secure my workloads in order to avoid am I breached. I don't want a lot of malicious user to come and access my applications. I really do not want a lot of unsecured access to my application, etc. So those all are aspects of security. And by security in this presentation, I only mean network security. So the things that have to do with securing your network elements is the second block. Third block is now you have landed on cloud. Now you have secured your application. How do you scale out? Which means today I am one application, tomorrow I'll be 100 applications. Today 100 user access my application, tomorrow million users might be accessing my application. So how do you scale your application and also the scale of the users who are accessing your applications? Last but not the least is the pillar of optimize. The pillar of optimization comes in two flavors. First is the cost optimization, the second is an architectural optimization. So now that you are in a cloud, you have secured it, you have scaled it up, you want to optimize your application access, which means unless you have a visibility into what is going inside your network, you might not be able to optimize. You are able to optimize something only when you have a visibility. If I put a black box in front of you and I say, go ahead and do whatever optimization you want to do, the answer would be that this is a black box. I really can't optimize anything. So optimization, visibility are are the concepts that really go hand in hand. And hence, the fourth aspect that I will touch upon is optimize. Now, let me jump on to the first pillar, which is the connect piece. And I'll now jump into the specifics of what happens inside a Google Cloud. The fundamental construct of networking in Google Cloud is a concept called VPC. Think of a VPC as the bare minimum thing that you would be required when you talk of networking inside of Google Cloud. A VPC is a global resource. By global resource, I mean that when you create a VPC inside of Google Cloud, let's say you create VPC number one, that one VPC is good enough to hold your applications in Americas, in Europe, in India, in Singapore, in Australia, wherever Google is present. So the difference between Google and some of the other players in this league is that our networking construct, which is VPC, is global in nature. We are not regional in nature, we are global in nature. That means if you really have an intention of deploying workloads anywhere in the world, you still end up creating and maintaining only one VPC. And that is the only VPC that you might be able to kind of run your entire business on. What does global VPC bring to you? Once you create a VPC, that is the fundamental construct, wherever you want to put a workload, you need to create a second construct which is called as subnet. So if you follow my diagram on the screen, uh, the blue box that I have shown is a VPC, but the gray boxes that you see are the subnets. So I wanted to host my application in US East and US West, hence I created two subnets. Subnet number one, which is for US West, subnet number two, which is for US East. As you want to expand your applications, you can go ahead and add more and more subnets to it. If you have to do any level of security, you will still do at the VPC level. This is different. This is different from a lot of other players where if this VPC was regional, then you have to write your security rules also for that region. However, since the VPC is global in nature, you have one VPC and you write the security rules once. The second difference in what a global VPC can help you is, let me take an example. There is a region, let's say region one, let me take it as Mumbai region, and there is a region two, which is, let's say, a Delhi region. As you know, within a region, there are zones, right? So when you create a subnet in a region, that subnet spans across all the zones. If you have to create a resource and you want to say that I want the resource only to be spun up in zone B, let's say I want my VM to only be in zone B, then you make that call when creating a resource. But when you create a network is global. When you create a subnet is regional. If you have to create a resource will be very zonal in nature. So if you want to create a VM in zone B of Mumbai, this is where you will go and create the regional zonal resource.
So Gaurav, sorry for interrupting. We have a couple of questions here which may be related to the current slide. So I thought it would be best to pick them up right now.
Mhm.
So the first question that I have is from Arnab Sarkar. Arnab wants to know, so where does Akamai sit in the picture?
Let me open the question. Where does Akamai sit in the picture? Okay, so Akamai is a CDN player. which plays into the area of caching. When I was explaining the very first slide, which had some numbers, the caching location that I shared on the screen is equivalent to EDN POPs of Akamai. The difference over here would be that some of the caching players across the world, they do not invest into these locations, they lease those locations. Versus what Google does is that a lot of these locations are Google owned, Google managed, and some of these are non-Google owned, non-Google managed. So if you have to equate what Akamai was doing to what the slide I showed, it is the caching locations.
Okay,
The
the
next
next question is what is the requirement of VPN here?
Okay, so I'll jump into VPN in a bit, but to answer your question right now, VPN is required to connect Google Cloud to the external Google Cloud. So if you are sitting at, let's say, your office and your office wants to do a site-to-site VPN to Google Cloud, that is where VPN comes into picture. VPN as a concept comes under the category of hybrid connectivity in the cloud. So if you want to connect a cloud to a non-cloud location, that is where VPN comes and fit into, and I'll share more details as I move forward.
Great, thanks a bunch. You may continue with the session.
All
We'll
right.
let you know if any other question comes in.
So now that you know what a VPC is, what a region is, and how do I spun up, let me fundamentally tell you how various constructs inside a VPC talk to each other. And sorry for the confusion. So in this diagram, very simple diagram, I let's say have five VPCs. VPC 1, 2, 3, 4, 5. As I told, VPC is a global construct. For VPC 1, I have two VMs, VM1 and VM2. VM1 is in, let's say, Asia East, and VM2 is in US East. Two subnets within a VPC can talk over a private IP. You just need to have a firewall rule for it. So if you just have one VPC, one subnet in Asia, one subnet in US, you want these to talk to each other over a private IP. Yes, they can talk to each other over a private IP. You just need to have a firewall rule, and the traffic of this IP stays on Google backbone. It does not go outside of Google. It stays within Google backbone, and hence this is going over a premium network anyways. Let me take a second example. There is VPC2 in US East. You spin up a VM. That VM wants to talk to public internet. For example, that VM wants to go, and a person on that VM wants to go and enjoy a YouTube video. He can go on a public IP and just listen to YouTube video songs. That is allowed fundamentally if you have a firewall rule enabling that. The third thing that I want to show is, since VPCs are standalone constructs on their own, by default they don't talk to each other. So if you make a VPC1 in your project and a VPC2 in your project, by default they don't talk to each other. So in this example, there was a VPC2 and there is a VPC4. There was a VM in VPC2, there was a VM in VPC4. By default, they don't talk to each other unless you do one of the things that I'll talk in coming slides. By default, over the private network, they will not talk. They can still go over an open internet and go and talk to each other, which is permitted or denied by the firewall rule. But by default, they will not talk over the Google backbone because they are standalone entities in terms of their management. Next, I would like to introduce couple concepts which is called as a standalone VPC and a shared VPC. And this is important when you go and think from an application owner point of view. Standalone VPC is nothing but it is standalone, it is isolated, it don't talk to anybody else. Which means that if you had a project, in this example, let's say prod project 1, you created one VPC, you created two subnets, one in Frankfurt, one in North Virginia. They had a lot of VMs in that. When the VM wants to talk to each other, you just created a firewall rule. That's it. And they started communicating with each other. You created second project. Again, you created one VPC, two subnets. As long as you enabled the firewall rule, they started talking to each other. So as you expand your projects, you can't kind of expand your VPCs and you manage those VPCs one by one. So if you have to make a change, you have to make a change twice, once in this VPC, second in this VPC. These are standalone VPCs. Now there is a second concept which is called a shared VPC, which requires some attention from you. One of the fundamental problem that we are trying to solve with the shared VPC concept is not everybody is a network expert. Not everybody fills in the shoes of a network admin. So uh, when we talk to our customers, on the customer sides, the networking team and the application teams are way apart. Application teams priority in life is I want to get my application working no matter what. Networking team is generally the team which gives the application team the required network stuff. So if the application team says that my application requires 30 IP addresses and my application is supposed to be listening on port 80 and port 443, these inputs are given by application team but fulfilled by the network team. So since there are different personas who do networking and who do application, why not we have our projects designed in the same way? That is where the concept of shared VPC come. Shared VPC can be broken down into uh, two constructs, one of which is called as a host project and second is called a service project. From an application owner point of view, you will only get access to a service project. This is the area where you will come, you will deploy your application and you will go away. So this is the area where an application guy will come and play. Host project is the area where networking guy will come and play. This is the area which will have VPC. So when a networking guy creates a VPC here, he will create a subnet here and he will share that subnet to an application owner. Which means if an application guy says, give me 32 IP addresses in Frankfurt, the guy will create a subnet, maybe a slash 27 or something. And that guy will create this subnet and share that subnet with prod one project. When the application owner logs in into his project, he will see automatically a network is available for him. He will always see that there are 32 IP addresses available for him and he will just start consuming it. He doesn't care who created it. He doesn't care who will manage it. He doesn't care who will write a firewall rule for it. He just gave those inputs to a network guy. Network guy did his work in the host project and just shared it to the application guy. So this fundamentally is a shift from doing a VPC by VPC management. The network guy did everything in one place and he shared the things across to the multiple application developers. This ease out the manageability and also the way the traffic moves. Now, coming to how a VPC in two projects talk to each other. The example that I was taking, there is a VPC 1 in project 1, there is VPC 2 in project 2. Fundamentally, they are isolated resources. They don't talk to each other. If you have to make them talk, then what? Then what are the ways in Google Cloud to make them talk to each other? Let me take a small example. Let's say project A is your development project. Project 2 is your testing project. And for a given stage of time, this dev and test project needs to talk to each other over a certain subnet. How many ways can you make them talk to each other? There can be more ways, but there are three ways at least that you should remember. The first is called VPC peering. What is VPC peering? VPC peering is just a way to tie the two networks together. Thing that you should remember about VPC peering is VPC peering is a binary concept. By binary, I mean it is either 0 or 1, which means that both parties, they either agree to do a peering or they disagree to do peering. There is nothing called gray there. So if the A and B wants to talk to each other, A say yes, I want to talk to B, and B says yes, I want to talk to A. That's when the pairing comes up. If one of these parties says no, I don't want to do a pairing, the pairing will never come up. That's one. Second is pairing is none or always kind of a concept, which means that if A pairs with B and B pairs with A, whatever subnets A knows, he will share to B, and whatever subnet B knows, he will share with A. That's like saying if two guys are friend, they share whatever they know to each other. None of them is greedy or none of them is a bad friend wherein the guy will say I'll take all your knowledge but I'll not give my knowledge. No, that's not how it happens in peering. Peering is very native way of saying that whatever I know I'll tell to you, whatever you know you tell to me, right? So that's how peering works. The beauty of peering is that the traffic of VPC peering flows on the backbone of Google Cloud. So if there are two projects, let's say project number one and project number two, when they peer to each other, there is no bottleneck anywhere. There is nothing like I can only send X Gbps of traffic from project A to project B. No, there is fundamentally no bottleneck. You can send as much traffic as you can because the traffic is now going and consuming Google backbone. The second concept that comes to connecting the two VPCs is VPN. And this is, I think, where somebody asked the question also. Let me take a small example. There are, and the VPN comes in various use cases. One of the use case I'm sharing over here. Let's say there are two VPCs, VPC number one and VPC number two. For whatever reason, you don't want to do peering, let's say. You didn't like the concept of peering, or there was some limitations in peering because of which you do not like to go with the peering. There's another way wherein you can connect these two VPCs, and that is called Cloud VPN. Cloud VPN, by the word VPN, the bell that rings in most of your mind is it comes with the flavor of IPsec, and hence the traffic goes on an open internet. That is partially true. When the two ends of the VPN tunnel are GCP, which means the first end is GCP VPC1, the second end is GCP VPC2. Yes, it is still a VPN, but I'm not sending traffic out. I'm still creating an IPsec tunnel over the Google backbone. You still see public IP addresses as the endpoints, but the traffic remains on Google backbone. The thing that you should remember about VPN always is VPN comes with its throughput. In GCP, when you create a VPN tunnel between point A and point B, the maximum throughput of that tunnel can be 3 Gbps, which means either you can send 1.5 Gbps up plus 1.5 Gbps down, but the overall throughput should not cross 3 Gbps per tunnel. If you have traffic which is north of 3 Gbps, create multiple tunnels. If you have, let's say, 5 Gbps, create two tunnels. That is where the complexity start increasing, and that is where you need to take a call. Was peering better for you, or was Cloud VPN better for you? The third thing that I've already touched, but I'll introduce this concept one more time when it comes to connecting the different projects. As I explained, in shared VPC, there is a concept of a host project and there's a concept of a service project. Service project is project where apps are installed, application guys are coming and playing there.
Just
Host project is
question I need to ask here. Sorry for interrupting. In the previous slide, you said the traffic remains in Google backbone. So what is meant by that?
sure. So if you understand how VPN works, there are two endpoints of VPN, and those two endpoints are public IP addresses. When endpoint number one and endpoint number two are both Google endpoints, which means you are creating VPC1, you are creating VPC2, and you are just trying to knit them together. The endpoints are Google endpoints still, which means although they are public IP addresses, the IP addresses are Google owned, and hence I don't need to send traffic out to an open internet. I can still keep it on the Google backbone. The throughput limitation still remains 3 Gbps, but the traffic is still on the premium backbone of Google. It is not going out on an open network. It is not going out an open internet. It is still on the Google backbone.
Gaurav, I have one question. You mentioned that the IP should not be overlapping, right? But
Mhm.
if suppose we are like my organization is occupying some another project or basically some another organization, and if feel like there is some overlapping happening in between the IP addresses, what would be the solution for that?
Okay, so VPN is not the solution for that. There are multiple ways you can consider connecting those two VPCs. I have not covering those, but some of those can be considering using a third-party appliance and doing something like a VXLAN, and then converting them into a tunnel packet. I am not covering those in this presentation, but neither peering nor VPN is going to help you in that scenario. The reason I'm saying none of those will help you is because when you bring up a peering, the first thing it will check is none of them are overlapping IP addresses. Otherwise, I can't handshake with you, right? When it comes to VPN, again, since it is a layer 3 concept, You advertise what you advertise what you want to, and I'll advertise what I want to, but none of these should be overlapping again. If you are in if you know some of the technologies that some technologies like VXLAN, you can still kind of play with that, and that is how you should be doing it. Or if you're really not in favor of kind of deploying a router like a third party router supporting VXLAN, etc., there are plays around natting of a third party, natting on a third party device, which you can still consider. But unfortunately, I did not plan to cover that in this session.
No problem.
If you,
Thank you.
yeah, are we good? Any other questions? Okay, I'll take that as a yes. On a shared VPC, I already covered. This is fundamentally how you connect a application project with a host project. Now you have connected various projects, but one thing that still remains is today nobody have um, not nobody's the wrong word, but a lot of players these days believe in the concept of hybrid cloud, and hence they say some of my applications are in cloud provider 1, some of the applications are in cloud provider 2. Or I'm in the middle of migrations, a lot of my applications are on-prem and a lot of them are on Google Cloud. So how do I establish these kind of connectivities? And hence I'm naming them under the concept of hybrid connectivity. I don't want, I don't plan to go very deep into it, but I just want to put a paint on it that again there are two buckets where this kind of connectivity will lie into. The very first bucket is what I said, VPN. So if you want to connect your data center with GCP, GCP has an offering called Cloud VPN, and you can do an open standard based IPsec between your on-premise VPN concentrator and the VPN on GCP. The throughput number still remains the same. 3 Gbps per tunnel is what you should be very careful about. So if you have a data center, let's say anywhere in India, and you want to connect a GCP region Asia South 1, which is Mumbai, go ahead and create an IPsec tunnel. The traffic will remain on internet because your on-prem is going to create a tunnel over the internet, and you can send 3 Gbps per tunnel on that. VPN also comes in two flavors. Most of people they deploy flavor number 1, which is a dynamic routing over the VPN, which means I support BGP. I can fundamentally advertise my routes over BGP, and your on-prem firewall should be able to support BGP for that. And this is covered under GCP offering of HAVPN, which is called highly availability VPN. If for whatever reason you are running very old firewall which does not understand BGP, you still can do something called as classic VPN in GCP. So there are two flavors of VPN. HAVPN is what we take to market. Classic VPN we are phasing out. But if in case you're running a very old, very legacy firewall in your data center which does not understand BGP, look out for the word called classic VPN and go that path. But in majority of the cases, I believe you will be doing an HAVPN.
Gaurav, is there any limit to how many tunnels we can create?
Um, there is um, there is a limit, but that number is a big enough number. I don't have that on top of my mind, but you can fundamentally do multiple tunnels and do a ECMP on those tunnels. I don't remember that number. That's documented in our limits and quota guide, which we have on the web. But that number is a big number.
Okay, okay.
Yeah. And this is exactly what I wanted to connect. I was about to answer that question. If your capacity is north of, let's say, 10 Gbps, and you believe that IPsec might slow down my performance, that is where the other flavors come into picture, which is called as interconnect. Interconnect again are two-folded. One is called as a partner interconnect, and second is called dedicated interconnect. Let me put some light on what does this mean. Partner interconnect is you have a data center. Let's say you have a data center in a remote location and you want to connect to GCP. You say that I'm not in the business of telecom. I can't lay a fiber from my data center to GCP location. I will bring in a partner in middle. So you went and had a word with, let's say, Airtel, or you had a word with Tata. You say, dear my friend, I'm already taking a lease line from you, or I'm already taking an MPLS connection from you. Can you extend that connection to Google Cloud? I want to access an application sitting in Google region. These all service providers, not all, but majority of these service providers are already connected to Google Cloud at a neutral location. We publish which all providers do we work with in the various countries. In India, let's say you are a subscriber of Tata. So you will go and talk to Tata and you will say that I need 10 Gbps connection to Google Cloud and I want a redundant connection. I do not want a single point of failure connection. That is what is called partner interconnect. You're bringing a partner in middle to do the connectivity on your behalf. How is dedicated interconnect different from you, and when you should consider a dedicated interconnect? Two things that you should remember. First is dedicated interconnect comes handy only if you can be in a place where Google is present. In India, we are present in 5 locations where you can do a dedicated interconnect with us. These 5 locations are Delhi, Mumbai, Chennai, Hyderabad, Kolkata. So if you are in one of these locations and you can bring in your fiber all the way to this place, that is where you should consider dedicated interconnect. Dedicated interconnect does not come in flavor of less than 10 Gbps. So if you say I can do a dedicated interconnect, but my requirements are 2 Gbps. No, dedicated interconnect is not for you. Dedicated interconnect comes at least 10 Gbps and north. You can give us requirements in multiple of 10 Gbps, like 10, 20, 30, 40, up to 80 Gbps, or you can give us requirement in terms of 100/200 Gbps. At the end of the day, Google will allocate those many ports on Google's router, wherein you can come and hook your direct cable into, and that's where you connect a data center to GCP. So answering your question, which someone asked a minute back, if your requirements are very low hanging, you want to start off really quickly, you got a requirement right now, and in an hour you want to establish a connectivity with Google Cloud, VPN is your best friend. The connectivity can be established in a matter of minutes. The VPN is straightforward, standards based IPsec VPN. No matter which firewall you have at your site, you will still be able to do a IPsec. Go ahead, establish it, start doing your work. If you have a requirement of, let's say, 20 Gbps, 30 Gbps, 50 Gbps, please consider dedicated interconnect. If your requirement is somewhere in middle, go ahead and talk to your service provider like Tata or Airtel. I will jump on to section number 2, and I'm sorry I'm running late. I might switch my gear, but if there are questions, please feel free to put it in chat also. When it comes to security, now that you have landed, you might be thinking about various security architectures or security questions that your CISO might be asking to you.
Last question. Sorry to interrupt you. Sorry for that. In the last slide, you explained about the Google provided circuits and all, Google provided bandwidth and all, right? So in Google provided dedicated fibers and all, the manageability from end to end for the fiber and everything would be of Google itself, right?
So I didn't say that we'll give a dedicated fiber. What I said is that we will give a location where you will bring your fiber and connect into.
Okay.
So there are 5 locations like Delhi, Mumbai, Chennai, Hyderabad, Kolkata. If you say that I can be in Mumbai place where Google router is placed, we will allocate a port for you. It's your responsibility to bring in the cable till that point.
So it's customer responsibility, right?
Yes, yes.
Okay. Thank you.
In terms of security, where am I? Hold on. In terms of security, these are the solutions, and I'll go deep into what these mean. But from security, what I really want to achieve, I want an end-to-end security architecture based on the outcome that our customer wants. We want some part of it to be automated, if not all. Security comes with a lot of requirements on insights. What have you secured? What have you denied? What have you permitted? What have you not permitted? Why have you not permitted? So can you give me those level of insights? And is that a reactive response, or was that a proactive detection and response? Now, these kind of go and fulfill into various buckets. Some of the requirements that you might be seeing often are that my workload, which is hosted in Google Cloud, should not be accessible from China. My workload is installed in Delhi, and it should only and only be visible to users in India. Or you might be seeing a requirement that as the threat landscape is increasing, go ahead and block the bad IP addresses. Now, what is bad IP address? You don't know what is bad, what is not bad. So you depend on something which is called as threat intelligence. All these requirements you will come and hear whenever it comes to security, and I'll try to address it as I move forward. But what I'm trying to say is that you will hear these requirements. You fundamentally have 5 to 6 products to play with to achieve what those compatible outcomes are. And if you can go and integrate these solutions with the overall architecture that I'm about to put on the table. Let me start drawing an architecture uh, so that you understand what and where fits. Let's say there is an internet user. He's coming and trying to access your web application, which is in Google Cloud. Your very first line of defense would be, if it is a malicious user, he or she should be blocked right at the edge of the network. Now, what is the edge of the network? I explained you in the very first slide. Those are those pop locations where you enter into my network, where you enter into Google's network. So that is the first place where you can mitigate those bad actors. And this is where first offering of Google comes, which is called as WAF/DDoS mitigation service by the name of Cloud Armor. Now, once that traffic is clean, it has come through in. Let's say you have a very great requirement saying that I want to do IPS plus IDS plus URL filtering, which unfortunately, let's say some of those is not met by Google Cloud's native service. You are free to bring in any third party service inside of Google Cloud and host them on a VM. Let me take an example. Let's say you are a fan of Palo Alto Firewall. You say that I'm used to do something in Palo Alto Firewall. Can I get the same experience in Google Cloud? Yes, you can bring your firewall Palo Alto license inside of Google Cloud and spin it up on a required VM. This is what will give you a third party firewall. You bring your license, you host it on a VM, and you manage that firewall. This is not a managed service for you, but this is customer managed service for you. And once when such arrangement is done, that is your second line of protection. These VMs kind of connect untrust and trust VPCs. So you will have something called as untrust. The traffic will come, you will clean it on this third party firewall, and you will send it to the trust VPC. Your third line of defense is that VPC anyways has a firewall. So you can still play around with that firewall, write your L3, L4 kind of a rules, and that is your third line of defense. So in this simple diagram, what I've shown till now, the north-south traffic has gone through 3 levels of protection. The first was at the edge, which is WAF. The second is you brought in your own firewall to do something fancy. And third is cloud firewall that anyways comes with the VPC. Now the traffic is going east-west, which means the web wants to talk to DB or a web want to talk to an application. You want these to be, let's say, port 80 allowed, port 443 allowed, rest everything blocked. When I introduced the concept of VPC peering, if you are connecting these two VPCs via peering, you can still play around with cloud firewall. You can write L3, L4 rules on these cloud firewall, and then you can do a peering of these two VPCs and route the traffic between them. If you really want to do a heavy duty firewall, route that traffic in a hairpin fashion on the same third party firewall. So this same third party firewall can be a north south firewall and can be a east west firewall also. This is where you can do a hairpinning also. Let's say you want to say that web the DB wants to talk to on-prem also. This is again where you can do a hairpinning, clean the traffic and send it via a on-prem VPC to a on-prem. Although NAT is not a security construct, but this comes when I'm discussing security. Let's say your on-prem is talking to Google Cloud, and you want to say that I will only permit traffic from certain whitelisted IP addresses only. This is where NAT comes into picture. So uh, any VM or any service which runs on private IP address, if it has to talk to open internet, it should go via NAT. When it goes via NAT, the IP address which NAT had, which is called natted IP address, is the IP that the traffic will go through, and that is what we should whitelist at your the remote side, which is your on-prem or the other side of the application. Now, what is IDS and what is packet mirroring? A lot of the time, the security requirement or compliance requirement is that we have to kind of do an intrusion detection. You can either use Google managed service, which is called Cloud IDS. The way the Cloud IDS works is you actually tell that this is the traffic that I want to go through Cloud IDS. I want to do a detection on, and you kind of fundamentally just give that traffic input into Cloud IDS. If you say, no, I am a great fan of an open source, I will do IDS myself. I have a lot of signatures with myself. I want to do it myself. please go ahead and use a concept called as packet mirroring. What packet mirroring does is it kind of mirrors some of the packets and send it to you. You do detection yourself. Last but not the least is a concept of service control. Now, if you look at this word VPC service control, please break it down into two parts, VPC and service. So when a VPC wants to talk to a service, where are your security controls? Let me take an example. If there is a VM wants to talk to a cloud storage bucket. You can fundamentally download something from a cloud storage bucket and send it to your personal Gmail. That's a breach. That's an exfiltration threat that you are suspected to. So for managing those kind of situation where a service was exposed to a VM and because of which either infiltration or exfiltration happened, is something that you control using VPC service control. Fundamentally, when it comes to network security, these are the layers where you need to tighten your screws to get security architecture in place. Most of you who are from networking background do understand firewall. In terms of GCP, a firewall that sits on VPC is a layer 3, layer 4 stateful firewall, which means that you can do a layer 3, layer 4 only. You don't do a layer 7 line kind of thing at this firewall. So things like I want to allow port 80 and port 443. Things like I want to block ICMP pings. Things like I want SSH traffic to come in only from these IP addresses. All this fundamentally you do at VPC firewall only. Now, VPC firewall also kind of have something called as network tags, which helps us achieving micro segmentation. So in this diagram, if I want to say the VMs which have tag of red should be allowed to be accessible from IP1. The tag which have the VMs which have tag of blue should be allowed to be accessible from IP2. That fundamentally we can achieve using those tags and these VPC stateful firewalls. Uh, Nothing great in this slide. Just to give you an idea that like any other firewall, the firewall rules are written by priority and these are evaluated top down. So if you have, let's say, priority 10, 20, 30, 40 rules, if there's a match on priority 10 rule, 30, 40 are not even evaluated and the very first rule gets evaluated. The action is only allow and deny. There is no other action on VPC firewall. And as I said, this is layer 3, layer 4 firewall only. Now you might be thinking that I explained you concept of multiple VPCs and connecting those VPCs together. Firewall rules sit on VPC, which means that I write a rule on VPC1 and I write on VPC2. If I have 100 VPCs, will I write 100 rules or will I write same rule 100 times? The answer is yes. If you are using VPC firewall rules, you have to write rule per VPC. That's how any networking in cloud works. But if you want to go with the fundamental thought that I will write once and it will be imbibed by multiple VPCs, then comes a concept called as hierarchical firewall. By hierarchical firewall, I hope you are aware of organization folder from the previous sessions. I can write a rule at organization level, or I can write a rule at a folder level, and this rule is inherited by project and VPC. So I'm writing rule once, but it is inherited by multiple VPCs which are in that project. So this gives me fundamentally a peace of mind that I want to define a security policy for my organization and it will be imbibed by whatever project sits in my organization, no matter what. I have to depict it in a different manner. This is how it looks like.
Gaurav, I have one question regarding the firewalls. Let's say I am deploying a third-party firewall like Palo Alto. So, from Google's perspective, is there any micro segmentation possible that which traffic I can, if I want to inspect a specific subnet or specific traffic, right? Is there any micro segmentation available? How I can do the inspection?
Okay, so it depends on where are you placing this third party Palo Alto. So let me take an example. If this third party Palo Alto firewall is put in a north south path, so when the north south traffic comes, it will first hit the untrust VPC, which you call as outside VPC also, and one leg of your Palo Alto will sit in that untrust VPC. That means user traffic first comes and hit this firewall. Till this point, this firewall does not even know what is the micro segmentation strategy of your Google Cloud. and hence you have to implement that at the Palo Alto. You have to define that my target group 10 10 10 0 is group 1, 10 10 20 0 is group 2, and this is how you should be routing the traffic. So your Palo Alto firewall comes much before your VPC firewall in this flow. But if you are using, let me take a second example now, but if you're using this firewall as a east west traffic, then your traffic which is going from VPC 1 first goes through your VPC firewall and then goes and hit the Palo Alto. Then you can exercise some control at your VPC firewall, by which you can say only the traffic from VMs which are red VMs should go towards Palo Alto as next hop. The traffic from the VMs which are blue VMs should directly go to internet gateway. That you can control. So it
Okay.
all depends
Sure.
on what is your architecture. Is it a north-south firewall? Is it a east-west firewall? And then kind of control that.
Okay. Thank you.
All right. So I will jump on and kind of, I
Hello.
hope.
Hi, Gaurav. Nikhil this side. I have one or two questions, right? So first one regarding when you mention about the micro segmentation part for the east-west traffic. So say if I have two VMs which are trying to communicate with each other and I'm putting a micro segmentation on at the VM level, so that basically kind of firewall you are applying at each level so that the traffic is secured. But does it not introduce some kind of latency, or does it not adds on a cost to my overall structure?
Okay. So you asked two questions: performance and cost. The
Correct.
fundamental thing which I did not told, but I would like to explain it a little more deeper is when you write a firewall rule in VPC firewall, actually the rule is compiled at your host level, which means if you have VM1, VM2, VM3, the rule that you have written at the VPC level actually sits inside your host. It is inside your Linux kernel space, if I may say that, right? So it does not introduces a hop wherein the traffic goes out and inspect the firewall and then comes out. No, it is right when the traffic is at your VM, that is where it gets through or it is denied there. So no performance bottleneck there. On the cost part, the firewall rules, I will again use the word firewall rules, which is layer 3, layer 4 firewall. Just saying this source going to this IP port 80 allow, this is free. We do not charge our customers for writing firewall rules. But for the concept that is on the screen, this is something called as firewall policy. You're doing a hierarchical policy. You're writing policy once and this is getting introduced at the lowest most level. This is charged. So if you are a hardworking guy, you can write rule twice. Write those rules at VPC level free of cost. We don't charge that. But if you say that I will write one golden policy that should be imbibed by all the VPCs, no matter how many VPCs I define, that policy is charged.
Got it.
I hope.
Thanks. And just one more question. So in the part wherein you mentioned that if I have traffic on my on-prem and I want to go into inside the cloud, right? And I'm using NATing in that case. But should we not prefer some kind of say jump server or bastion host to probably route that traffic inside instead of directly talking to the VMs, or NATing is the okay option?
It is. I mean, see, natting is an egress concept. So when a VM inside of your GCP wants to go out, this is where natting comes handy. So if I have a VM which is private IP address and it wants to do a patch download, a Windows VM or a Linux VM, it wants to do a patch download, but the IP is a private IP. That is where NAT comes handy. So it goes via NAT. Bastion host example that you took is for the incoming thing. So if you are sitting in your office, you want to access workload, come and access my Bastion host and then come inside my environment. So fundamentally, two flows
Got
in
it.
can be natting.
Thanks a lot, Gaurav.
Yeah. So I will skip this in the interest of time. I am done with section 2. I hope no pending questions till now. If yes, I'll take it after the section 4. Now that you understand VPC, I hope you understand some part of security also. The second problem which might be at top of your mind is everything is great, but how do I scale my environment? Today I'm at 1 VM, I might be 100 VM tomorrow, and I'll be 1000 VMs day after. How do you scale with GCP? I don't want to jump too many stairs at one time, but what I want to say is the very first construct that comes to your mind when it comes to scalability is the concept of a load balancer in a networking discussion. Load balancer I hope some of you know what a load balancer is, but if I have to divide load balancer in any cloud, a load balancer is either a global load balancer or a regional load balancer. My global load balancer, I mean, it will have a anycast IP address no matter where your users are. They are in US, they are in Europe, they are in Australia, they are in India. They will still get one IP address, and that is where it will come and hit the load balancing layer. And this IP is called anycast IP address. Versus a regional load balancer is the load balancer which is very regional in nature. When you try to make that load balancer, or when you try to spin that load balancer, the very first thing that the Google Cloud console will ask you is which region are you making this load balancer in, and hence it is for that region, it is for workloads of that region only. So fundamentally there are two types of load balancer. Let me take what is a global load balancer. A global load balancer is the load balancer which is used most of the times, and this is a proxy load balancer. What is proxy load balancer? A proxy load balancer is a load balancer that terminates the incoming user session and starts the new session. I'll repeat, proxy is something that terminates incoming client session and starts the new session towards the backend. Pass-through load balancer is the load balancer that just passes through the connection. It does not terminate that session. All the global load balancer that you see on the left, HTTPS load balancer, SSL load balancer, or TCP global load balancer, they are proxy load balancers, which means they will proxy the connection first and then send to the backend. However, the regional load balancer that you see, the network TCP UDP load balancer, this is a pass-through load balancer. Now coming on to what is an internal load balancer versus what is an external load balancer. Internal load balancer is for sending the traffic to your internal resources only. Let's say a web wants to talk to a DB, but there are multiple DB instances. I want to load balance between the DBs. That's an internal load balancer. I don't want to send traffic out. My load balance connection comes from within Google Cloud, and my terminating host is also within Google Cloud. I just want an internal load balancer. That is where you fundamentally make these use of these two internal load balancers. Now, putting some more color to what an external HTTPS load balancer is. No matter where you are, you get one IP address, which is called as any class IP address. You land on one of those Google POPs, which I explained in my very first slide, and that POP will route the traffic to wherever your healthy backend is. Healthy backend is a backend which can serve your client request. What is a proxy load balancer of a TCP and SSL? Again, if your incoming request is you want to do an SSL offload, etc., you kind of do that you deploy a load balancer which can proxy your request, terminate it at one of the edge location, and then do a backend load balancing towards the healthy backend. I mean, you might be thinking both of them are proxy load balancers. So why does Google have three different load balancers? HTTPS load balancer is only for the type of traffic, which is HTTPS, port 80, port 443 kind of a traffic. TCP SSL load balancer are for special use cases, wherein if you have an application which does not work on 80/443, works on other ports of TCP, this is where you have TCP load balancer. SSL is when your incoming traffic is of the type SSL and you want to do a SSL offloading kind of a use cases. So these are our external load balancers which are global in nature. Let me take an example of a TCP UDP load balancer, which we call as a network load balancer. In this example, this is a pass-through load balancer. In addition to this being a pass-through load balancer, if you see the same diagram, I have a user in US, in New York, and in Singapore. The IP address that this load balancer has given to you are three different IP addresses. The reason these are three different IP addresses is because this is regional now. I have spun up a load balancer in a region. So if I have www.travel.com, which is in Singapore, I have one IP address. I wanted to do a second load balancer in a region, maybe New York. I created a second load balancer, and hence this is very regional construct that I'm introducing. When you do this type of construct, the concept of doing a DNS based forwarding to one of these IP address is your responsibility. So you have to play smart at the DNS layer, that if the incoming request is from US East, I will send it to this IP address, and this load balancer will then serve the traffic from the instances running in the US region of GCP. Having said that, what is an internal load balancer? An internal load balancer is nothing but which routes the traffic internal of GCP. So if a request came in, I want to send it to a lot of database servers, my internal load balancer comes handy. Now the internal load balancer can be passed through, which is what I have shown on the left. And again, by this internal load balancer, there is nothing like man in the middle. This is again SDN driven load balancer, which just gets deployed using our SDN layer. There's no choke point in middle. Another question which I think somebody asked in the beginning of the session around Akamai, not exactly um, covering the architecture, which is a media slash caching architecture, but this is how generally it looks like. When a user is requesting a object, it can be an image, it can be a file, it can be a media file, etc. When it is trying to access that image, the very first request comes and hit at the caching layer, which is the CDN. CDN sees if I have that object in my cache or not. If the object is in the cache, it returns it, and that is called as cache hit. If the object is not in the cache, that is called as cache miss, which is where the CDN goes and say, I need to fetch the content from backend. That is where it goes to the load balancer and tells to load balancer that there was a request coming in for, let's say, www.example.com/file1. Please route it to the appropriate place where I can find this file. This is where the load balancer comes in. It tries to find a file, is either it is on cloud storage or is it on one of the VMs, etc. It kinds of fetch that file, feed it into CDN, that is called cache fill. So when the content is filled into the cache, is served to the user. That's how the overall framework works. The beauty of CDN is the CDN caching layer is very near to where you are, and that is where decreases the latency and you kind of get that file ASAP. There are two flavors of CDN that Google have, and I'll not jump deep into that. One is called as Cloud CDN, and that is called Media CDN. They address two specific use cases. Cloud CDN is for static objects. Like if you are into a business of website delivery, you have a lot of GSS files, JavaScripts, HTML pages. That is where Cloud CDN comes and fill the gap. If you are in a business of media, like you have a lot of videos, games, audio files, that is where the second product of Google comes in, which is called as Media CDN. Just remember two words. There is a cloud CDN, there is a media CDN, and based on your requirement, you can actually go and deep dive into one of these products and the architectures associated.
Hi, Gaurav. Just one
Yes.
quick thing.
Mhm.
As we are towards the end of the session and in the interest of time, I would request you to cover the most important topics in the fourth section and slowly wrap it. We will just have last 5 minutes to announce few important aspects.
Sure. I'll
Sure.
be done in like 6-7 minutes.
All right, thanks.
All right. Now, last, you are now landed, you are secured, you are scaled out. Last is obviously it would be of your interest to see what more optimization can I do with GCP, and is there a visibility into what has gone in. Don't think that having your application inside GCP is like a black box for you wherein you don't have any visibility. I'll break visibility chapter into only 4 parts, although there are multi aspects of it, but only 4 parts as of now. The first is visibility comes at each stage of your cloud journey. When you are in a stage of choosing a cloud provider, should I choose GCP or should I not choose GCP? This is where first level of visibility might be required. So you might be required to figure out, is GCP's performance better than XYZ performance? Do I have some numbers to back up? Yes, at that point of time, you might require some visibility. Either it come natively or it come non-natively is where you need to kind of compare your on-prem performance with the cloud performance, etc. Second, when you are decided to go on Google Cloud, this is your second level of visibility requirement comes in, wherein you will be figuring out, should I have my application hosted in Mumbai? Should I host my application in Singapore? My users are in New York. Where should I host my application? What is the cheapest place for me to host my application? This is where you require to do a lot of network planning, and hence migration questions also comes into picture here. This is where you require some level of visibility also. Third is obviously when you are in a steady state business, your business as usual, This is where your operations team might kind of ask you a lot of questions that I had a P1 downtime yesterday night. Was it because of network going down or was it because of an application misbehaving? I had a downtime yesterday night. Was it because of Google performance getting down, or was that my project somebody made a change and because of which the application was down for a few minutes? So you need a lot of visibility into day two ops also. Last but not the least, you might require to do an optimization of cost as well as architecture. To do that, we have a framework called Network Intelligence Center. It is like a Swiss Army knife, which has multiple sub modules under it. The first module is something called as topology. Excuse me. Topology is like a living graph for you. This tells how your instances, how your load balancers, how your network looks like inside of Google Cloud. How much traffic came in, how much traffic went out, who, who was the most chatty workload, etc. is something that you figure out in a network topology. This gives you enough visibility to figure out is your network behaving fine or not. And hence you can address use cases like monitoring, troubleshooting, etc. here. The second dashboard that you should always be looking into is called as a performance dashboard. Performance dashboard addresses two things. It is packet loss and latency. So if you are even wondering that what is the latency between Mumbai and Singapore, or if you're wondering what is latency between New York and Frankfurt, this dashboard will precisely tell you what is the latency between one Google region to other Google region, or from an internet endpoint to a Google region. And then you can kind of decide how much latency was your application giving to you, and was that a Google problem or was that your problem. The third thing is something called as connectivity test. People coming from network background think it of multiple steps ahead of what traceroute used to do. Traceroute used to tell you my application when it is trying to access, let's say, IP address 1, which hops does it go through. This is multi-step ahead of that, which it wherein it will tell you which hops does it went through. Not only that, but it will tell you if your traffic was dropped because of routing issue, because of firewall issue, because of load balancer issue, and whatnot. So in this diagram that you see on the left, on the right, uh, the traffic came in from this IP address. It landed onto a firewall rule. It landed onto a load balancer rule. Load balancer dropped the traffic. That's why it is red. And the reason it dropped the traffic is because there was no healthy backend. All the workloads were crashing in the backend. That's why it said it is 0 out of 3, and I was not able to deliver the traffic to the backend. If you did not had this kind of visibility, you would be troubleshooting this at multiple layers and to eventually find out that where was the issue. So this is where connectivity test comes very handy. Last but not the least, firewalls are very troublesome things when it comes to troubleshooting. If you have 100 firewall rules and you have no visibility, and your manager or somebody in your CISO organization comes and tell you that please clear off the rules which are not in use, trust me, this will be one of the nightmare for you to kind of go and find out which firewall rule you can delete easily. This is where firewall insights come into very handy, and you can easily try to find out things like which are the rules which are deny but a lot of hits are coming in, which are the rules which are allow but actually there was no hit in last 60 days, or which are the rules which are shadowing each other. And hence you can make use of these insights to make a better optimization of your firewall. With that, I think I am done with my content that I plan to cover. Isha, all yours.
Thanks, Gaurav. I think this was a really interactive session overall. I'm sure students might have some questions to ask. So, anyone has any questions before we go ahead and announce few aspects from our side? In case you have any questions, just raise your hand. And by the time you do that, I think I'll just quickly hand it over to Ashay to make a small announcement regarding the popular question that we have been asked on the chat window regarding the Google Cloud Skills Boost Labs. So over to you, Ashay, quickly for that.
Thanks, Isha. Hi, everyone. This is Akshay, and I could see a lot of questions in the first couple of minutes of the session about the deprecated lab in the GCCF with Kubernetes course on the Cloud Skill Boost platform. So I just want to confirm that all the deprecated labs are already removed, and you could see all the labs are available and handy. All you need to do is re-enroll yourself in the course by just unenrolling in the course and enroll it again, so that you will see all the labs are removed, all the deprecated labs are removed, and all the healthy labs are there. So yeah, this is what I wanted to announce. And if you have any question related to it, please do ask. Thanks.
Sure. All of you, please make sure that by this we are not. It does not mean that any of your progress will be affected. It will all be as it is there.
Yes.
So we have a person looking to ask a question, Pradeep.
Hello, good evening, sir. If we are enrolling it again, then we can lose the points.
Yeah, I guess that's what Isha has just said, that the progress what you have made so far will be as it is. You just need to unenroll and enroll in the queue.
That will not affect our GCP points that we have to pursue the
Right.
lab.
It is neither going to affect your credits or nor it's going to affect your progress, and everything that you have achieved so far in the course will be intact and it will be visible on your public profile URL. So let's assume that you have completed the entire course and you're just waiting for that particular deprecated lab. So just re-enroll in your course, and basically your course will be counted completed. As I've already mentioned in one of the question and answers asked today, that your performance is overall evaluated on 25th of every month, and within 10 working days, if your course is counted completed, you will get a joint course completion certificate, right? So this is all in place, and just re-enroll yourself and don't be worried, your progress will be intact.
Thank you, ma'am. One more question is there. I have completed all the part of that program, but still I didn't get anything.
So yes, Pradeep, as I'm mentioning, you might have completed it recently, this program.
Exactly date I'm not up.
Sure.
So
So what will exactly happen is that on the coming 25th, your performance is going to get evaluated if you have completed the entire course and on the 5 course badges, which are also displayed on the landing page. So those 5 course badges, if you have it in your profile, which means that your course is completed. If your course is completed within 10 working days, you're going to receive the joint course completion certificate through Nasscom, through the FutureSkills Prime team.
okay, ma'am, because actually I have gotten like a course badge. Okay, badge I have
Mhm.
received, but the course completion certificate not. So that's why I'm asking for that.
Yes, Pradeep, that's what exactly I'm answering. You might have received the course completion badge for the first 4 courses, and you are stuck with the 5th course badge, right?
No, ma'am, I have received all 5 batches.
Okay, if you have received all 5 of them, then very soon this particular month we'll be evaluating the performance, and just wait till first week of Feb and you'll receive your course completion certificate.
Okay, thank you, ma'am.
Great.
Okay, on that note, I would like to barge in. So first of all, thank you, Ashay, for populating the important information about the labs. And thank you, Gaurav. That was tremendous as a session. And I know you've covered and packed in a lot within time. So we have already taken the questions during the session. One last chance to ask any technical questions related to today's topic. You may go ahead and raise your hand. In the meantime, I would like to let everybody know that just for the benefit of everyone, the recording of this session will be available on the FutureSkills Prime YouTube channel. So if you go to the YouTube and you search for FutureSkills Prime, you will get to our channel and you will see this recording posted over there. This will also be handy to you in the closing email, which should reach out tomorrow to your registered email IDs. I also want to reiterate, like there are certain questions about the Nasscom assessment and about the completion and certificate. So beginning from the joint certificate, so first and foremost thing is that you complete all the 5 courses. Once you do that, towards the end of the month and beginning of the next month in which you have completed the course, you will receive the completion certificate, because as Isha told you that the completions are evaluated on the 25th of every month. So it's possible that if you have completed it today, you will only get the certificate at the end of the month, because your progress will be evaluated on the 25th of this month. So that's one related to the joint certificate. In terms of Nasscom assessment, so I want to tell everyone that when you complete these courses, as Nasscom, we have developed the assessment for this particular program, and for a nominal fees of rupees 600. So you can take this assessment and also get an assessment certification. That this is something that adds tremendous value to your CVs as well as to your job applications. Also, we are working very closely with Isha and team to bring more programs from the Google Cloud fold. So you can keep visiting FutureSkillsPrime.in, which is where you will see the additional programs that we bring to you from Google. So talking about the Nasscom assessment, I'll just share my screen and show you exactly how you can work around in terms of the assessment. So this is the course pathway that you would see on the FutureSkills Prime page. Now, if you see this card has, this particular pathway has 4 cards. So one is Google Cloud Computing Introduction. So this is just an infographic to give you how information on how you can progress. This is the actual course which you would have enrolled for. Once you have completed this particular course, you would be, this card gets unlocked, which is the mock assessment. Remember, you just have one chance to take this mock assessment. This is a remote proctored mock assessment, and it is multiple choice based. So I saw someone asking the type of the assessment that will be available. So it's multiple choice. Once you complete this mock, irrespective of the fact that you passed it or failed, this will be unlocked, the 4th card, which is the actual assessment, for which you will have to pay a nominal fee of 600. So until here, everything is free. You attend the mock and then you take the actual assessment, for which you need to pay the 600. So this is how you need to complete your actual assessments for Nasscom. Now, because we are really over time, so if there are any questions of yours which are left unanswered, I've just mentioned the email IDs on the chat. So you can go ahead and write to us. These are the support IDs. So first one is support@futureskillsprime.in. You can mention the course name, send in your query, we'll get an answer to your email. The second, if it's specific to the Google Cloud course, you can write to support@quicklabs.com. And again, specific to that particular course, the Google Cloud team will be happy to get that question answered for you. Just to recap, the recording of this session will be available on the YouTube channel. Please search for FutureSkills Prime on the YouTube and you can access this recording there. We'll continue to do more programs like this, hopefully at a monthly schedule, and we'll try to make it as frequent as possible. And we look forward to catching up with you again. So if you have any specific questions, even technical ones, we'll try our best to answer them. With this, I would like to bring the session to a close. I'll really want to thank to all the participants and the panelists too. As it's late evening, you've taken the time out, you've invested time in your learning and skilling. We are grateful for that. We hope we have been helpful to you. We always value your feedback, so please write to us at the support IDs, and see you again on the next webinar. Thank you, everyone. Thank you very much. All the best.